In this episode, we take the concept of private service endpoints and scoped connectivity and turn it into a decision-making skill, because in real architectures you rarely get to choose between perfect security and perfect convenience. Instead, you choose between trade-offs, and you want those trade-offs to be intentional, repeatable, and aligned with risk. Private endpoints can reduce exposure by keeping access paths inside controlled network boundaries, while public endpoints can be simpler for distributed users and globally reachable applications. The tricky part is that both approaches can be built securely or insecurely depending on how identity, permissions, monitoring, and operational practices are handled. Beginners sometimes want a single rule like always use private endpoints, but cloud security decisions are rarely absolute. The goal here is to help you decide when private endpoints are worth the added complexity and when public exposure, paired with strong controls, can be the right choice. If you can explain the factors that push the decision one way or the other, you will be able to reason about architecture rather than memorizing preferences. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by framing the decision around what you are protecting and who needs access, because those two questions set the baseline. If a service holds highly sensitive data, such as customer records, credentials, or regulated information, reducing who can even reach that service is often valuable. If the service controls other services, such as management planes and orchestration, it is also high value because compromise can cascade. On the other hand, if the service is intentionally user-facing, like a public website or an API designed for external consumers, hiding it behind private networking may not match the business need. In that case, you still secure it, but you secure it with strong identity, rate controls, monitoring, and careful design rather than by making it private. So the first decision factor is exposure intent. Is this service meant to be reachable from the internet, or is it meant to be internal infrastructure? Private endpoints tend to beat public exposure when reachability is not part of the service's purpose, because public exposure adds attack surface without adding business value. When reachability is part of the purpose, private endpoints may not be practical as the primary access method. Next, consider the threat model, which is a plain language way to describe which attackers you are worried about and what opportunities you are trying to remove. Public endpoints increase the number of potential attackers to essentially anyone with internet access, which means you will see more scanning, more brute force attempts, and more opportunistic exploitation. If your organization is frequently targeted, or if you operate in an industry where attacks are constant, reducing that global exposure can be a meaningful risk reduction. Private endpoints force many attackers to gain an internal foothold first, which typically requires more effort and creates more detectable activity. However, private endpoints do not eliminate threats like compromised internal accounts, malicious insiders, or compromised workloads inside your environment. That means private endpoints are most compelling when your biggest risk is opportunistic external attack and when you can reasonably control internal access boundaries. If your environment already has weak internal segmentation and poor identity hygiene, private endpoints might create a false sense of safety rather than real risk reduction. In beginner terms, private endpoints are a strong move when you want fewer strangers knocking, but you still need to make sure the people inside the building are properly checked. A third decision factor is how distributed your users and systems are, because connectivity is not just a security choice, it is a usability and reliability choice. If your applications run inside a controlled network environment, like a well-defined cloud network segment, private endpoints often fit naturally because your workloads are already inside the boundary. If your users are employees working from many locations and devices, or if you have partners and third parties that need access, private endpoints may be harder to use unless you build additional secure access layers. Public endpoints can be simpler for distributed access because they rely on global routing and do not require private network integration for each user. But that simplicity comes with increased exposure, which means you must compensate with strong identity enforcement and careful monitoring. Private endpoints beat public exposure when the consumers of the service are mostly internal workloads that can reliably use private routing. Public exposure can be acceptable when the consumers are legitimately external and when you can enforce authentication and authorization strongly. The key is that you should not choose public access solely because it is convenient in the short term if the service is not meant for broad reachability. A fourth factor is the sensitivity of errors, meaning how badly things go wrong if you make a small mistake. Public endpoints are unforgiving because a single misconfiguration that weakens access control can be exploited quickly by external actors. If you accidentally allow anonymous access, accidentally grant broad permissions, or accidentally expose a management interface, the window between mistake and exploitation can be very short. Private endpoints provide a buffer because even if you misconfigure permissions, the service might still not be reachable from the internet, which can buy you time to detect and correct the mistake. This does not mean private endpoints make mistakes safe, but they can reduce the speed and scale of exploitation by limiting who can reach the service. This is especially valuable for services that are frequently modified or managed by many teams, because more change usually means more opportunity for error. If you have a fast-moving environment where changes happen daily, reducing public exposure can be a practical way to reduce the risk that a single slip becomes a breach. Beginners should understand that many headlines come from small mistakes combined with broad reachability, so reducing reachability can reduce the consequences of inevitable human error. Operational complexity is another key factor because security controls that are too complex often get bypassed, which undermines the whole goal. Private endpoints typically require coordination between networking, service configuration, and application design, and they often depend on reliable internal routing and name resolution behavior. If those pieces are fragile or poorly understood, private endpoint deployments can cause outages or intermittent failures, which creates pressure to revert to public access as a quick fix. Public endpoints can be easier to integrate quickly, especially for teams that are not network-focused, and that can reduce time to delivery. The security question is whether the organization can support private connectivity as a durable standard, not as a special project that only a few experts can maintain. Private endpoints beat public exposure when you can implement them consistently and support them operationally, because consistency reduces exceptions and exceptions are where risk returns. If the organization cannot maintain private connectivity reliably, then public exposure with strong controls may be safer than a private design that teams constantly work around with insecure shortcuts. Another factor is observability, meaning how well you can see what is happening and respond when something looks wrong. Public exposure can generate large amounts of background noise from random probes, which can make it harder to spot meaningful anomalies unless your detection and alerting are mature. Private endpoints reduce that external noise, which can make internal access patterns clearer, but only if you have good logging and monitoring inside the boundary. If your internal observability is weak, private endpoints can hide problems because fewer people are able to notice them, and you may not see abuse until it is advanced. The best position is to pair either approach with strong observability, but the decision depends on where you have visibility and where you lack it. If you have strong internal logs, baselines, and anomaly detection, private endpoints can help you focus on high-signal events. If you primarily rely on internet-facing monitoring and you have weak internal telemetry, moving everything to private paths without improving visibility might reduce your ability to detect certain threats. Beginners should take away that connectivity choices and detection capability are linked, because you cannot protect what you cannot see. A particularly important architectural factor is whether the service is part of your internal data plane or your external product surface. Internal data plane services include storage, databases, messaging, and internal APIs that your workloads use. External product surface services include user-facing web endpoints, public APIs, and content delivery points. Private endpoints generally shine for internal data plane services because those services usually do not need to be reachable from the open internet, and they often contain high-value data. For external product surface services, private endpoints are usually not the main solution because customers and external systems need to reach you. In those cases, you focus on strong authentication, careful authorization, and defensive patterns like minimizing data exposure and monitoring abuse. In some architectures, you can mix approaches by keeping internal dependencies private while exposing only a thin public edge that is designed to be hardened. This concept of a hardened edge with private internals is a common security posture because it limits what is reachable publicly while still supporting external business needs. Beginners should see that the question is not private versus public everywhere, but where private endpoints reduce risk the most without breaking the intended access model. When you decide, you also want to think about blast radius containment, because that is one of the most consistent benefits of scoped connectivity. If a service is reachable publicly, then any authentication weakness can lead to broad access attempts from anywhere. If a service is reachable only from certain network boundaries, then even compromised credentials might be harder to use unless the attacker can operate from within that boundary. This containment effect is stronger when internal segmentation is strong, meaning not every internal workload can reach every private endpoint. If you have tight segmentation, private endpoints can help ensure that a compromise in one application does not automatically grant network reachability to all services. If you have flat internal networks, private endpoints may still reduce external exposure, but the internal blast radius could remain large. That means private endpoints beat public exposure most clearly in architectures that already embrace boundaries, because private connectivity becomes one more boundary that reduces lateral movement. For beginners, it is enough to remember that private endpoints are most powerful when they are part of a layered boundary strategy, not a single magic switch. Ultimately, deciding when private service endpoints beat public exposure comes down to aligning reachability with purpose, aligning exposure with risk, and aligning complexity with what the organization can sustain. Private endpoints are often the better choice for internal services that store or process sensitive data, for management and control surfaces, and for environments where small configuration errors could have high impact. They are especially valuable when the service consumers are internal workloads that can reliably use private routing, and when the organization has the operational maturity to implement and maintain private connectivity consistently. Public exposure is often acceptable or necessary for services designed to be consumed by external users or systems, but it demands strong identity enforcement, careful authorization, and robust monitoring because the attack surface is larger. The best architectures usually combine both approaches, exposing only what must be exposed and keeping internal dependencies private and tightly scoped. If you can explain these factors and make a reasoned choice, you are practicing cloud security as architecture, not as superstition, and that is exactly how you prevent reachability decisions from becoming future incident reports.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.